you understand that this is a power. I cannot distribute -1. This is a power. I have to raise this to the power and then multiply, but I cannot raise it to a power. So what's outside has nothing to do with the radical. So what do I have to write? I have to write an inequality. What is the inequality I have to write? And then solve to find the domain. It's the same problem. What do I have to write?
Greater or equal to 0.
What?
Oh, the 2x plus 16 is
Indeed.
greater than...
Indeed. So 2x greater equal to -16, x greater than or equal to -8. So the domain of this function is bracket at -8 to infinity. This is extremely important for what follows in math. Being able to find the domain of a rational function, the domain of a radical function, and so on and so forth. So since 1/8 is in this domain, no problem. So negative 2/8 plus 16, negative outside, 2/8 is 1/4 plus 16. I have to find the least common denominator, which is 4. And I have to multiply. 64 plus 1 is 65, divided by 4. The only thing I can do is separate into the square root of 65 divided by 2. The square root of 65 is 65 because it's 5 times 13, I think. What is 65?
Did you put 2/8 in it?
Yes, and I simplified it to 1/4. No, I put 1/8. 2 times 1/8.
Oh, right, okay.
That's okay.
I missed that part.
Was it something else? Did I plug in something else?
No, I just missed that part when you're doing it.
Okay, so 1/4. So 64 plus 1 is 65. And then the square root of 65 is the square root of 65. What is 65? So it's 5 and 13. So there is nothing we can do. So the simplified form is negative the square root of 65 over 2. For the last one.
Where did the 64 come from? And then the 65?
When I add two fractions that don't have the same denominator, I have to find the least common denominator, which is 4.
Mm-hmm.
I have to multiply the numerator by 4. 4 times 16 is 64. 64 plus 1 is 65.
Perfect. Okay, thank you.
Better?
Much better, thank you.
Good. Find the domain. Excellent. What is the inequality that I have to write to find the domain of this function? The square of x plus 1. I need the inequality that I need to write and solve.
X plus 1 greater than or equal to 0?
Very good. So x greater than or equal to -1. So the domain is from -1 to infinity. Very good. This is it. That's all we need. Good. F of x, the square of 9 minus 7x. Which inequality I have to write and solve to find the domain?
Nine minus 7x is less than...
Can never be less than. There is no such thing.
0?
The quantity underneath has to be positive or 0. It can never ever be less than. So -7x greater equal to -9. We divide by -7. What do I need to do when I divide or multiply any inequality by a negative number?
Make positive.
You mean when we multiply or divide.
You mean negative times negative or divided?
So I divided both sides by -7.
Yep.
What do we need to do? When we divide both sides of an inequality by a negative number or multiply by a negative number.
Plus.
Nine.
Yes, indeed, from greater than or equal to less than or equal to. So
Oh,
the
right.
so the domain here is -infinity to 9/7. Do we get the idea with domains of radical functions? And you see the interval notation is what matters, not the set builder notation. They never asked for that. Good. What about the domain of this function? What would you have to write and solve to get the domain?
Well, it would be pi.
So what do I write? What is the inequality?
That'd be
So this is w of x. I'm going to replace it by x. So the 4th power 2x minus 7. Okay, so what do I have to write? What is the inequality that I have to write?
7/2.
No, I have to write an inequality. 7/2 means nothing. What is the inequality?
2x minus 7 is greater or equal to.
Indeed. So 2x greater than or equal to 7 and x greater than or equal to 7/2, which is an interval. 7/2, comma, infinity. Is that clear? We're not trying to find the zero. We're trying to find the interval. So we have to write this inequality, step by step solve it. That's why we studied in Mod 7 to solve the inequality to determine the domain.
So the 4 doesn't even matter.
It does. But not when I determine the domain.
Yeah, like when we're doing the domain, we just ignore that.
For every even, whatever this is, the quantity underneath has to be greater than or equal to 0. If it's odd, I will not write anything. There is no restriction for odd.
It's infinity.
But if the index is even, that makes this quantity mandatory to be greater than or equal to 0. First, I look here, but it doesn't come into the calculations. It
When
does.
it's even, I was going to say, when it's even, you need to have an equal, greater or equal to something.
Exactly, greater than or equal to 0.
But when it's odd, it's infinity.
You don't have to write anything. So if I'm given this function, let's say f of x equals the cube root of 2x minus 5 or minus 4, whatever, I will not do anything. I'm done. Because it's the cube root. A cube root can be determined no matter what.
Is there a logical reason for that?
Yes, I can, because this number exists. I can raise this number to an odd power to get this. I can raise this number to an odd power to get this. I can raise this number to an odd power to get this. But I cannot raise a negative number to an even power and get positive.
Yep, that makes sense.
Okay, so here we are asked to find the domain of this function. And then graph it, and then we're going to look at and find its range. Okay, so first of all, this g of x is the square root of 7 minus x. Perfect. What inequality do I have to write and solve to get the domain?
Negative x plus 7 is greater or equal to 0.
Very good. So negative x will equal to negative 7. I multiply or divide by negative 1. And I have to
Flip it.
Very good. So then the domain is -infinity to 7 with a bracket. This is extremely important because they're asking me to graph it. And I need to know where the graph will show. It will show anywhere between -infinity and 7. So the negative 10, 10, which is the standard viewing window, is good for this function. So I go to the graphing calculator, I clear everything, and I just put that the square root of 7 minus x. I will use the standard viewing window by clicking on Zoom Standard, Zoom 6. Here's the graph. So the graph of this function, as expected, is between negative infinity and 7. 1, 2, 3, 4, 5, 6, 7. I'm just copying it. So this is the square root of 7 minus x. From the graph, can anyone identify the range?
Greater or equal to 0 to infinity.
0 to infinity. So the domain negative infinity to 7, and the range from the lowest to existing y value to the largest existing y value.
Wonder why they did range from the bottom up. I mean, I guess it's negative to positive. Never mind. I just answered my own question.
Good. I love it. Good. So let's also look at this one. Because we kind of talked, we did talk about something like this. We never graphed it. Obviously, the domain is very simple here, because I only have the square root of x, not the square root of x minus 7. This is different. So, and we know how to graph the square root of x. This is the simplest radical or square root function. So this is square root of x. Can anyone remind us what will the square root of x minus 7 look like? Where do we drag this function?
Down 7?
Exactly.
Yeah, it's y minus 7.
1, 2, 3, 4, 5, 6, 7. So this is the square root of x minus 7. What about the range?
Range would be minus 7 to infinity.
Yes, from the lowest to the highest. So the range, minus 7 to infinity indeed. Very good. Good. Determine the domain. Excellent. Can anyone give us a domain of h of x? The cube root of x plus 4.
Infinity.
Everything.
Negative and positive.
Everything. It's the cube root. We don't have to, we have no restrictions to write, nothing, nothing, nothing. Good. They're asking us to graph it and then find the range. Okay. We graph this together, but not exactly this function. We graphed only the cube root, the base function. So here's my preference. I put x plus 4, and it has to be in parentheses. If you are using this method, you have to put the caret, and because the cube root is power, 1/3 indeed, and close. Standard viewing window is fine, so I'm just click on graph. Here it is. So it's opening upward in this way, and then of course at -4, and then it goes up. So here's the graph. Can anyone give us the range?
Everything.
Yes. 1, 2, 3, 4. So this is the cube root of x plus 4.
Yeah, odd powers are the easier ones
Exactly. And why does this go to the left? Because the x-intercept is at -4, and -4 plus 4 is 0. Good.
For some reason, when I put that in my calculator, it always gives me error invalid dimension.
You're probably not plugging it in, right?
Did you enter it like this, x plus 4?
Let me see if I can show you.
Does it show at the very top you have a plot? Are these any of these highlighted?
Yeah, plot 1.
Okay, so you have to do this. Second and stat plot, and make sure that all these are off.
Oh, okay, yeah. Plot 1 says on. How do you turn it off?
So you click on it and go from on to off.
Oh, okay. Okay, now I'm gonna try it.
And now it's going to work.
Yes, it did. Okay, thank you so much.
My pleasure. Good.
Well, that must have been frustrating then if you haven't been able to do
It's awful.
Good.
Okay, made me click off everything.
that.
Yeah, you had the plots on. Okay. Moving on to something a little bit more interesting. Solving quadratic equations by factoring, and which we know, and then completing the square and then the quadratic formula. Okay. Yes, I know I only have, what do I have? 9 minutes? 9 minutes. Okay. Other methods of solving quadratic equations. The first, say it again?
Is this 8.5?
Yes. No,
Yeah.
this is,
6.
so these are the last two sections, 8.6 and 8.7.
Okay, thank you.
Thank you. Okay. We know one that is factoring. The second one is taking square roots. Which I did not see in the topics. The third one is completing the square. And the last one is the quadratic formula. And this is where the course ends. I will also show you this. Right now, this is done. We spend weeks on factoring. For this one, I need a little bit more time than 9 minutes. So I'm going to complete this one, the quadratic formula, right now. So I'm going to leave these two for Thursday. And that is the end of the course. Okay, let's talk about the quadratic formula. If I manage to arrange, and I should always be able to, arrange a quadratic equation in this format. If it's not in this format, I cannot use the quadratic formula. Then, all I need to do is follow the steps. Notice that A is the leading coefficient. B, it's taken with a sign in front, is the coefficient of the middle term. C, taken with a sign in front. This will always be positive. Why? Because I will multiply or divide by -1. I refuse to solve a quadratic equation with a negative leading coefficient forever. You will never force me to. I will always multiply or divide by -1. I will never ever solve a quadratic equation with a negative leading coefficient. You can do it if you want. Will you get the same thing? Of course. But I will never ever do it. Why? Because I don't want to have a negative leading coefficient. And the solution of the answer will be the same. Okay, here's the formula that we need to memorize. Negative b plus or minus the square root of b squared minus 4ac over 2a. And this has to be in your memory forever. 30 years from now, if I call you in the middle of the night at 2 a.m. and I say, what is the quadratic formula? You have to say, are you crazy? But then you have to say, yes, I remember. It's negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so here's an example, and then I'll stop. Let's suppose I have negative 2x squared plus 4x minus 3 equals 0. Okay. And you asked me to solve it using the quadratic formula. I will multiply both sides by negative 1. 2x squared minus 4x plus 3 equals 0. I have a, which is 2. I have b, which is negative 4. I have c, which is positive 3. I carefully plug them in. Remember, this is b squared. This can never be a negative number under the square root. The answer under the square root may be negative, but not the b squared, ever. Okay, so then I have x equals negative b, 4, plus or minus b squared, 16, minus 4 times 2 is 8. 8 times 3 is 24, divided by 4. And I will right there say the following, not real. How come? Because under the square root, I have the square root of negative 8. So I will not continue. Okay, so what if I have 2x squared minus 4x minus 3 equals 0? I changed the problem a little bit because I want you to see the final option. b, negative b, plus or minus b squared minus 4 times 2 times negative 3 divided by 2 times a. Now this is okay. So x equals 4 plus or minus 24 plus 16, 40. The square root of 40 over 4. I have to simplify, but not 4 with 4. I have two options. And the square root of 40 becomes, so x equals 4 plus or minus 2 the square root of 10. One option is x equals 4 over 4 plus or minus 2 the square root of 10 over 4, and you simplify individually. Or the other option is you factor out 2. And we get 2 plus or minus the square root of 10 over 4. And we can simplify now. And the answer is the same. This is condensed and this is separated, but they are identical. That's all about the quadratic formula. So a is 2, b is negative 4, c is negative 3. Negative b, the opposite of negative 4, plus or minus the square root. You don't care what b is. When you square it, you get a positive number. Negative from the formula. b squared minus 4 times a times c. But I have two negatives here. So 6 times 4. So it's positive 24. 24 plus 16 is 40. I simplify the square root of 40 as we've discussed. 2 and 10. So the square root of 4 and the square root of 10. Do not cross 4 and 4. That will be terrible. You either separate and you get this, and you simplify each fraction by itself, or you factor out the 2 and you simplify the factor and you get the same answer.